What's up, guys? Welcome back to the channel. Here we are talking about some more 7th grade standards with scale and distance and how those work together. Okay? So, don't forget, hit that subscribe button and like and comment if you have questions or if you want to see more. I know you guys really like seeing Tommy too, so I'm sure he's going to make an appearance, don't you worry. I just wanted to bring up real quick kind of what we're going to be looking at here before I bring Tommy in. And that is, again, 7th grade distance and scale and how those go together. So I'm going to read this problem. We'll bring Tommy out to help us out. All right, so this map is a scale drawing of the streets in a town. The scale from the town to the map is 500 feet to 2 centimeters. What are the actual distances in feet of the library, town hall, and the train station from the school? So you got to picture this. In real life, you know, the only reason we know the distance of things, obviously, is because we Google it. Back in the olden days, and this is weird, they used to look at maps. What? And they'd have to read the maps and figure out where to go? Yeah, that's how it worked. It's similar here. It's kind of like how when you're looking down at your GPS or whatever and where your car is and where the turn is, obviously they're not the same thing, right? When Siri says, you have in 400 feet, turn right. I mean, obviously on your map it doesn't look like 400 feet. It's the same idea. So that's what we're going to be looking at. We're going to be looking at 3.5 centimeters. What's that in comparison to this scale? 4 centimeters and 4.5 centimeters. With that in mind, let's bring out Tommy.
No, I don't want to.
But what do you mean you don't want to?
I'm tired.
Well, sometimes we get too tired to do math, Tommy, but we got to do it. What are you? Get up here.
Oh, man.
Tommy, remember how I told you in math it's about taking risks. It's about trying it. Even when you're tired, you've got to keep trying. Because what happens when you keep trying?
Oh, man. I get it eventually.
Exactly. You get it eventually. And that's fun.
No, it's not.
It is fun.
No,
Yes.
no,
Yes.
no,
Yes.
no,
Yes.
no.
Tommy, it's fun.
Okay, fine.
It can be fun. It just takes getting used to. It takes practicing. It takes trying. All right? And then you get some fun things you start to figure out, and we're good. Don't do it.
Oh, come on.
Don't do it.
Oh, come on.
Go ahead.
You know what you guys should do? Comment below if you think math is fun. Do it. If you don't, say no, it's not fun. And then tell us why. And if you do, say fun.
Okay, you don't have to get your face in the...
But it's funny.
It wasn't. Okay, back to where we were, Tommy. So, here is how we're going to do a problem like this. This is really important, okay? Especially with scale, there's a word I've talked about before, which is called the unit rate. Do you remember stuff about the unit rate, Tommy?
Let's see. Yeah, isn't that where, like, one of the numbers has to be, like, a 1 or something?
Exactly. One of the numbers has to be a 1. Example, this right here, would that be a unit rate?
No, because there's no 1.
Exactly. So that's not. What about this one?
Yeah, because it's a 1. 1, 1, 1, 1, 1.
Exactly, a 1, right? Okay? So that's how we make it a unit rate.
Nick,
Yeah.
I don't see any 1s in the problem.
You don't see any 1s in the problem? That's a good point, right? We don't have any 1s. So this is where the unit rate comes in big handy because we can find it.
Oh, how?
Well, we know that 500 feet represents 2 centimeters, correct? Is that a unit rate?
No, there's not a 1.
Exactly. But you can turn anything into a unit rate by turning one of them into 1.
Really?
Really? It's pretty easy. Do you know how to turn something into 1, Tommy?
Just scratch it out and make it a 1?
You could scratch it out and make it a 1, but that's not really how you do it.
It's not? That would be so easy. Why can't it be that easy? Look, just take the pen.
Hey, stop with the pen. No, Tommy, no.
Done.
Tommy, that's not how that works.
Yes, it is. Look, it's now a unit rate. You're angry. I can tell you're angry. Take a deep breath.
Okay. Can we fix it?
Yeah, sorry, go ahead. He's angry.
I'm just upset that you didn't get, just,
Okay.
here we go. So, back to where we were. How do I turn something into 1? What are some different ways that I can do it? Let's look at the 2. We'll start with the 2. What are some ways that I can turn a 2 into 1?
Oh, you could take away 1.
I could take away 1. You're right, I could do that. Problem is, that doesn't, because this right here is a fraction, 500 over 2, okay? Just subtracting 1 isn't going to change it to a unit rate because this is technically a division problem. So the only way to either do something with division is divide itself, or I can multiply, things like that. Subtracting is a little bit different, because I would do this. If I had subtraction, I would have to do this. It's equal to, take away 1. But really, if you're taking away 1, you have to have the same denominator, okay? So that makes this really tricky. It doesn't really work that way. So,
Okay, I give up.
no, don't give up. Think about some other ways. Go ahead.
I could, I could divide. Yeah, divide.
What would you divide by?
2. 2 divided by 2 is 1.
That's very good, you're right. So 2 divided by 2 makes this 1, right? So you divided by this by 2 in order to get to 1, right? So do I just put a 500 here?
Yeah.
Nah, see, and that's where this is tricky. You can't, because what you do down here, you're required to do up here.
So, since I divided by 2, I have to do it again?
Exactly. You divide the top by 2.
Oh, I see.
Yep, so what's 500 divided by 2?
250.
Exactly, so that's 250 feet. So you just found, I know it's a little bit sloppy,
It's not too bad.
thanks. You just turned that into a unit rate. Okay? So now 250 feet is 1 centimeter.
Okay, but how does that help? I don't get it. How does it help?
Okay, I get it. I'll explain how it helps. Relax. So what you're going to do is, now that you know the unit rate, you can find any other distance in feet.
Okay, how? I give up.
Okay, well, if you know the unit rate, you know that 1 centimeter. Well, look at these guys here, right? You want to know, when is 3.5 centimeters? What is this thing right here, right?
Yeah, so?
Okay, well, think about what we did over here. We divided by 2 to turn this into 1, right? How would I turn anything like 1 into this kind of number?
You multiply it by itself, so 3.5.
Exactly, so I'm going to multiply 1 times 3.5, right?
Yeah, what you do on the bottom, you do on the top.
Exactly, so I'm going to multiply this by 3.5, okay? So now 250 times 3.5, okay? Remember how to do this?
Yeah, you're going to have to move the decimal at the end. The end, move it.
Yeah, exactly. So 5 times 0 is 0, 5 times 5 is 25, 5 times 2 is 10, so 12. Put a placeholder 0.
Yeah, very important.
3 times 0 is 0, 3 times 5 is 15, carry the 1. 3 times 2 is 6, and 7, so I get that. And how many times do I move the decimal, Tommy?
Once, because there's one number after the decimal. Decimal!
Exactly. So I'm going to move the decimal 1 time, and we get 875. So the distance from the school to the library is 875 feet. Notice how easy it was once I had the unit rate?
Yeah, it made it really, really easy.
Exactly. So now I can do that same thing. Since I have the unit rate, I know it's 250 feet is 1 centimeter. Okay? And I now want to know how far does the train station. So what do?
Multiplied by 4.
Exactly. Multiply by 4. So I'm going to multiply this by 4. And the numerator?
Same thing.
Exactly, same thing. And 250 times 4 is 1,000. So that is 1,000 feet from the train station. That's 100. There's 1,000.
This is so easy. So then you take 4.5 and you multiply that by 250 also.
Exactly. You're getting it. Okay? So that's how you use distance. Okay? Just as well. I know what I have to do.
You're silly. You're super, 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 super silly.
You're silly. Is that making sense, guys? Question below if you're confused, if you don't know what's going on. Just do a quick reminder again. But basically what, oh, I forgot I can do this. Watch this, Tommy.
Oh my goodness, that was so easy.
I know, I should have done it that way the first time out. So, again, as a reminder, you're always going to take the scale that it gives you, that guy right there,
Yeah,
and turn it into a what?
a unit rate.
Exactly. You turn it into a unit rate by,
Doing division.
exactly, division. Divide by 2, divide by 2, and you get 250 over 1. This basically gives you all the keys now, okay? So basically, since the scale is 250 over 1, you're just going to multiply each one of these by 250, right? Because 4.5, 4, so on and so forth. Does it make sense?
Yeah, I think I get it.
All right. Let's look at another example just to make sure.
More math.
More math. Okay. So last one. You can do this, Tommy. Here we go. So now if we look at something like this, like the Eiffel Tower, notice those are two shapes.
Yeah, I see it.
Okay? It tells you that each inch in the drawing represents 400 feet.
Okay, so 400 feet and 1 inch.
Exactly. 400 feet to 1 inch. What do you notice?
It's already a unit rate.
Exactly. Since it's already a unit rate, all we're going to do is we're going to take each one of these heights, so that's 1.5, and that one's about 2.5. We can round it because this says approximately.
Oh, yeah, I see it.
So I would take 2.5 and multiply it by 400, and then I would take 1.5 and multiply it by 400, and then this says how much taller is the actual Eiffel Tower than the Space Needle. So I'd find my answer and subtract. Notice, I made it easy because I have my what?
Unit rate.
So basically, you need to turn all these into what?
Unit rates.
Exactly, into unit rates. Hope that helps, guys. Don't forget to subscribe.
Subscribe!
Just relax, dude. Seriously. That way you guys can see the math videos as they come out and get some help. And again, if you want some help with a specific topic and Tommy and I can help you, we'll make a video. Sound like a plan, Tommy?
Oh, yeah.
You're so ridiculous.
No, I am not.
Yes, you are pretty ridiculous.
No.
Yes. Huh.